Hello there, this is Alana, and I'm going to be working on 11.3 in Excel. Unfortunately for us, 11.3 is going to be really long and involved, but hey, it's the end of chapter 11. Okay, so I'm going to start off with a problem that is actually an even numbered problem. I know it's rare, but I have to do it because it's one of the few left-tailed tests in the whole homework assignment. So I'm going to be working on 11.3 number 6. Now you can see I've typed information in right here. They gave us x1, n1, x2, and n2, so I wrote them up. And they also asked us to state the null and alternative hypotheses, right? But they gave us the alternative right here, p1 less than p2, so I just wrote that up. So my null is that p1 equals p2, my alternative is that p1 is less than p2. And these are, of course, independent samples. They tell us right there, these are independent samples. Now, for my own benefit, I wrote in what alpha is, because that's step 2 anyway, so I figured, hey, I might as well. Step 1 is up here when you enable your null and alternative hypotheses. Okay, now, I'm going to need a whole bunch of stuff in order to figure out the test statistic, which is what they want for part B. So let me go back and look at the formula down here. There it is. This big honking thing is the test statistic, and it's kind of a pain to calculate. So what I did was I first found p1 hat and p2 hat, and I do that by taking x1 divided by n1 for p1 hat and x2 divided by n2 for p2 hat. And then I also found p hat. I do that by taking x1 plus x2, see that, in parentheses, because you got to have that joined up in the numerator. Then you close your parentheses and then do division, divide symbol. And then you do another parentheses and you add up n1 plus n2. Enter. All right, and there's your p hat. Okay, so now I found the numerator of this test statistic. That's pretty easy. You just take p1 hat minus p2 hat. Great. And then I'm going to do the denominator. It's this big, ugly square root thing. So I want the square root of p hat, which is in cell B8 for me, times 1 minus p hat. And then I close those parentheses off. Times. And now I do another square root. And then 1 over n1 plus 1 over n2, and I close that parentheses. And then I just take that numerator and divide it by that denominator, and I have my test statistic of negative 0.345. All right, that's part B. And again, I really recommend separating this. You can do it all at once, but it's kind of a giant pain. All right, so then let's go back. We need to find the critical value, I believe, next. Part C, excuse me, find the critical value, which we know is step 4 if we're doing this in the classical method. All right, so let me just show you the picture down here. So it's a left-tailed test, so I'm going to use Z alpha. So that means I'm going to use all of it. So I wrote it down here. Critical value is Z alpha, and this is the Z curve. This is not a T curve, so I get to use norm dot inverse. I get to use all of alpha, so 0.05, comma 0, comma 1. And if you don't have Excel 2010, it's just norm inverse, 0.05, comma 0, comma 1. There you go. Yes, I know there are other ways to get that if you're freaking out on me, but I'm just choosing that method to do it. Okay, so I've got my critical value, and just FYI, this was step 3 in a hypothesis test, this one. And down here, what we're doing right here is step 4. And then we found step 1 and 2 up here, just in case you want to keep track of what you're doing for a hypothesis test. Okay. Poof, I highlighted the parts they were really interested in. Now, part D, they want a p-value. Okay, so to find the p-value, we're going to have to find equals norm dot dist, all right, of that test statistic, right there, negative 0.345, comma, the mean is 0, standard deviation 1, true. Now, it works out nicely for us that it's left-tailed like that, because since it's left-tailed, that actually works out to be exactly the p-value. If it was right-tailed, then I would have to do the opposite of it and make it negative 0.345. But since it already is negative 0.345, that's my p-value. And hopefully you can see that if you were doing a hypothesis test on this, you would totally not reject the null hypothesis, right? Because, well, here, let me write out the answers. There we go. So if it was classical method, we would say we don't reject because the test statistic, which was negative 0.345, is not in the critical region. The p-value method, it's because the p-value, which is 0.364, is not less than alpha.